Okay, next we're gonna do examples to see how to solve for the non-homogeneous second order linear ordinary differential equation. Okay, so actually, if you go through your notes, there are a lot of examples. So we cannot go through all examples in the video because actually, you know, the steps are the same. So I just selected some examples, and you can try the rest of the examples which are not covered in the video on your own, because as long as you can follow the steps and propose the YP and do treatment and find the coefficient, then you're going to be fine. So in the notes here, so you have different types of right-hand side function. So I just selected 4 out of the many examples. Okay. Right, so let's go through one by one. So we're going to start with example 5, number 1. I'm just going to check if it's really recording. Okay, good. Okay, so let's do this first example. So the first step is to, of course, solve the homogeneous part. Then we write down the characteristic equation. I think my pen is a bit too thick, so I'm going to make it thinner. So, okay, m squared minus 3m plus 2 equals to 0. Then you check the b squared minus 4ac is negative 3 squared minus 4 times 1 times 2. So you have 9 minus 8 equals to 1. This is greater than 0, so you have real and distinct roots. So you can factorize the m. M minus 2 and m minus 1 equals to 0. Your M1 is 2 and your M2 is 1, or vice versa, doesn't matter. And thus your proposed complementary solution YC is equal to C1 E M1X plus C2 E M2X. So YC is C1 E2X plus C2 EX. Right, so moving on to the next step, which is the right hand side. So we're gonna solve for the non-homogeneous part, i.e. now you have the general form of Rx equals to E alpha X Pn of X, and your equation here, your Rx is just Ex. It's a warm-up question. Okay, so your Rx is Ex, so your alpha is 1 and your n is 0. So there's no polynomial. So you can propose your YP. So proposed YP is AEX. So you look at your value of alpha here is equal to 1, and that your alpha is actually same with one of the m value here. It's equal to m2. So then we need to do some treatment, because if we were to stick with this value of YP, it would be linearly dependent to the second YC here. So AEX is linearly dependent with C2X. So we need to do some treatment. So we propose YP to be equal to AXEX. Okay? Such that this YP is now not linearly dependent with the C2X. Right, so next we're gonna solve for the coefficient of YP. So the third step is to check whether YP and YC is linearly dependent or not, and we did that. So this is our new proposed YP. Now we're working on the determining the coefficient. So we start with YP equals to AXEX. Then we find out what is the YP dx. Yeah, this one you need to do the product differentiation, and then you differentiate the second derivative, AXEX plus AEX plus AEX. Then your second derivative is AXEX plus 2 times AEX. Okay, so what's next is that we put this and this and this into the original ODE. So the ODE given to us is d2y dx squared minus 3 times dy dx plus 2y equals to ex. So we put this into that. So d2y dx squared is this. So we put that ax ex plus 2a ex. So that is a second derivative of y minus 3 times dy dx. So dy dx is this. So times ax ex plus aex plus 2y. So y is ax ex, then equal to ex. Okay, now we are going to compare the coefficient. So collect all the similar terms together. X ex a 3a plus 2a plus ex, you get 2a. So here is, this whole thing here is 0, so you can just ignore this term. Then you have negative a ex equals to ex. So you can compare the coefficient. Negative a equals to 1, thus a is negative 1. Thus your yp is ax ex, right? So your yp is negative 1, or just negative x ex. That's your complete or total solution. Y total is yc plus yp. So yc is c1 2x plus c2 ex plus yp. So yp is a negative x ex. So this is your solution to the first question in the example 5. Okay. So the next example that I'm going to work on, I don't want to go through the question 2 because it's quite lengthy. Not yet. So I am going to do question 3 and 4 first, then I'll come back to question 2. So let's do that. Okay, so let's do this one. Okay, so write down the characteristic equation, m squared minus 4m minus 12 equals to 0. You want to check the b squared minus 4ac? Negative 4 squared minus 4 times 1 times negative 12. 16 plus 48, yeah, it's greater than 0. So you have two distinct roots, m minus 6 and m plus 2 equals to 0. So m1 equals to 6 and m2 equals to negative 2. So your yc is c1 e 6x plus c2 e negative 2x. Okay, now work on the right hand side. So your Rx is x e for x. So compare that with the general form of Rx, Pn of x. So your alpha is 1 and your n is 1. So your yp is thus a times e for x times a polynomial that is of a degree 1. So we don't put a because we already got a in front. Bx plus c. Okay, and since your alpha is equal to 1, it's not equal to any of the m here, so lucky. So we just say that yc and yp are linearly independent, so no treatment needed. So we'll work on the yp. So the yp, then we find out what is dyp over dx, the differential of y with respect to x. Yeah, so we need to do the product rule. So I'm sorry. I did an error. So here, yeah, you don't need to put an A outside there. So you just put B. Yeah, just re-look at your example. Okay, so if you have a combination of polynomial and the exponential, so you just can put the particular solution as the exponential and put the constant in the polynomial. Okay, you don't have to put extra coefficient there. But I think if you even if you put, you will end up with getting just equal to 1 anyway. So, but we don't want to waste time there, so we just yeah, follow this one. So put e for x and differentiate ax plus b, you got a. So you get a here, and differentiate e for x, you got 4e for x, and just take this ax plus b down. And then you can differentiate again to get the second derivative. For a, e for x, but the second term you need to do some product rule. Okay, so then your second derivative is 8a e for x plus 16e for x times ax plus b. Then what's next is you put this into the original ODE. So the original ODE is d2y dx squared minus 4 dy dx minus 12y equals to xe for x. So d2y dx squared is 8a e for x plus 16e for x times ax minus plus b minus 4 times dy dx. So dy dx is ae for x plus 4e for x times ax plus b minus 12y. So your y is e for x times ax plus b equal to xe for x. The next step is to compare the coefficients. So you need to collect all the terms together. Okay, hope you can get the whole line. So then, yeah, let's collect all the terms together. So you collect e for x. So you got, I don't know, 16b minus 16b. Well, you need to do it on your own also, okay? And check if I did any error. Then we collect all the terms on x, e for x. Then I get 4a minus 12b times e for x plus minus 12a times xe for x, xe for x. Then I compare the coefficient. Well, since there's only xe for x at the right hand side, so I can only compare that directly. So negative 12a equals to 1. So a is negative 1 over 12. And then this term here is equal to 0 since there is not any e to the 4x at the right hand side. So 4a minus 12b equals to 0. And b is thus 4a over 12. And since a is 1 over 12, 4 over 12 times negative 1 over 12, 1 over 36. Then you can put this value, yp is e for x times ax plus b, right? So your yp is now e for x times 1 over 12, is it negative? Yeah, and times x minus 1 over 36. So this is your yp, but not yet done because the total solution is complementary solution plus particular solution, yc plus yp. So complementary solution was what just now? C1 e 6x plus C2 e negative 2x plus e 4x times negative 1 over 12x minus 1 over 36. So yeah, now only your job is done for this particular example. Okay. So, okay. I think I'm gonna take a break here and we'll continue with question 4 and 2 in another video.